Assalamu alaikum students. So our today's topic is rewriting equations in standard form. Rewriting equation in standard form. First, let's look at the horizontal ellipse standard form and the vertical ellipse standard form. Now, we need to make sure that in between x and y, we have a positive sign. And it's always equal to 1. So whatever number is, we need to divide by that number other than 1. Okay, and we need to make sure that they are complete squares. X and y are complete squares. So if they are not in complete square, we have to make sure that we should be making it to complete using completing the square method. Now in this case, I see only there is one term of x, which is x squared, y squared. They have a positive sign in between. Now what I need is I should have 1 here, and there should be no coefficient next to x and y. Okay, there should be no coefficient next to x and y. So what I'm going to do, I'm going to divide throughout by 225. Okay, what I get here is this divided by this gives me x squared over 25. Oh, over 9. 225 times 9 is 25. And then 9 divided by 225 is 25, and this is equal to 1. Now here I know that it's in the standard form and it is the vertical ellipse because the larger number is under 1. Okay, make sure they have positive sign in between and it's equal to 1 always. Then it's in the standard form and there is no coefficient next to x or y. Now in this question, we can see that there's x squared term, y squared term, and there is x term which equals to 28. So first of all, I need to complete the square. Complete the square in the standard form. There should be x plus y. So I'm gonna combine x terms together. Okay, plus the y term equals to 28. My x terms are 4x squared plus 24x. I'm combining them. I'm combining y squared, separate y squared equals to 28. But still, it's not a complete square. This is a complete square, equals to 28, but this is not a complete square. To complete a square, make sure the leading coefficient, so I'm only considering this part now. I factor out this 4 here because for completing the square, my leading coefficient, my square term should have a leading coefficient of 1, then it's easier for us to complete the square. So I'm going to factor out 4 from here. I get x squared plus 24 divided by 4 is 6x. So to complete the square, I need, if you remember from the last topic, I need b over 2a. To find the third term, I do b over 2a and I square it. My b is 6 here. 6 divided by 2a is 1. 3 squared. So my third term is 3 squared. Okay. Plus y squared equals to 28. Now whatever I added here, I have to add it on the other side, right? I added actually 9, and don't forget that it's not equivalent to 9. It is 9 times 4, 36, because there is 4 outside. So what I added, I added is not 9. I added is 36 here. So I'm going to add 36 on the other side also. This becomes a complete square. 4, this stays here, x plus 3 whole squared plus y squared equals to, when you add them up, it's 64. It's still not in the standard form. It has to be equal to 1 and there should be no 4 here. So I am going to divide each side by 64. Everything by 64. So that this becomes 1. What I left with is this and this cancels out and becomes x plus 3 whole squared over 16 plus y squared over 64 equals to 1. Now this is in the standard form. Now it's vertical ellipse with a center of -3 and 0. Got it? Let's do one more question. And then we are done with this topic. Let's do question number 11. So here we have x squared, 4y squared, 16. Bring all the x and the y term to one side. I will rewrite it as, when this comes to that side, becomes 150x plus 4y squared minus 16y equals to 159. I'm separating the x and y term with the plus sign in between and leaving this 159 on the other side. So it should be, there should be one more term here, plus I'm just combining the y terms. There should be one more term to complete the square. So still the leading coefficient is here. I have to factor this term out, 4 and 25. So I'm going to factor out. I get 25 outside. I get x squared. 150 divided by 25 is 6x. There should be third term. I'm going to take it out. We're going to figure it out. Factor out 4. The leading coefficient should not be any number other than 1. Okay. So to get the third term, b over 2a. b over 2a squared. So which will be 3 squared. This would be, let's do b over 2a squared, which is 8. Oops, I did not factor out. It is 4. 16 divided by 4 is 4. And it is -4 and it is 2 squared. Right? Plus 2 squared. Now what I added throughout, sorry, it was 16 divided by 4, it's 16, not 4. Now what I added is 9 times 25, which is 225, okay? So I added 225. I also added 4 times 4, 16. That's why I'm balancing the equation. So this becomes 25, complete the square, x plus 3 whole squared plus 4y minus 2, because we got a -2 whole square, if you remember. And it's an alternate sign y. Oops. 4y minus 2 whole squared equals to, when we add all that, it ends up with 400. Okay, divide by 400 throughout because it's not in the standard form yet. What I end up is 25 divided by 4 is 16. So I get x plus 3 whole squared over 16 plus y minus 2 whole squared over 4 divided by 400 is 100 equals to 1. Okay, so this is again a vertical ellipse with the center of -3 and 2. Assalamu alaikum. Oh, before we end, eccentricity. What eccentricity is? The eccentricity of an ellipse is the ratio of C to A. And E is C to A. The value is always, this will be always between 0 and 1. How does this eccentricity help us? Eccentricity helps us to determine how circular or stressed an ellipse is. If the value of E is close to 0, if E is close to 0, then the ellipse it's circular. if E is closer to 1, it's stretched, more stretched. So we can have some examples. Here it's stretched. So E is more closer to 1. If you do C to A, the ratio of C to A, 5.2 divided by A would be closer towards something, 0.9 something. And the eccentricity of an Earth is closer to that, is closer to 0. That's why it's more circular. The Earth, it's not round. It's close to a circle, but it's not. It's an ellipse. Okay, so let's figure out how to find eccentricity. It's easy. We need to know two things: C and A. We know A squared is 49. So A would be 7. To find C, I know C squared equals to A squared minus B squared, which gives me, when I do 49 minus 36, I get C squared equals to square root of 13, and C is equals to, let's do C equals to square root of 13. Now let's find out E, the eccentricity. Is it elongated, or it's stretched, or it's circular? So let's do C over A. We will end up with 0.52. So it's not that elongated, it's not that circular, it's in between. Okay, now let's do question number 14. A is 5. Because A squared is 25, so A is 5, and to find C, we do A squared minus B squared, which is 25 minus 4, which is equal to 21, which gives us C equals to square root of 21. Now let's find out E, the eccentricity, which is C over A. It gives me approximately equal to 0.92. So in this case, our ellipse will be elongated or stretched longer, and it's going to be a horizontal longer like this. Okay, and this would be more like a circle in between. Okay. Assalamu alaikum.